So let's describe a system, a very simple system, to understand basic moments. Say we have a beam, and at one end, 5 metres from one end, we have a 2 Newton force, and at the other end we have 2 Newton force. How do we work out the moments in this system? You can probably see intuitively that because the beam is balanced at the centre point, that both of these moments are going to cancel each other out, but let's just show that mathematically. We know that the moment is always the force times the perpendicular distance. And you look at the force and look at the line of action of the force, and to find the perpendicular distance, then you need to take a line that is perpendicular to the line of action that goes back to the pivot point. We'll call that point P, the pivot point. So here the force is 2 newtons and the perpendicular distance is 5. Two newtons times 5 metres is equal to 10 Newton metres. And because it's in the clockwise direction, it's negative. Okay, so you write down what the moment is from this force here. Okay, so the moment here from this force is similar. It's a line of action down here, straight through, and the perpendicular from the line of action back to the pivot point is along the beam. So the force times the perpendicular distance is equal to 2 newtons times the length of that moment arm there, which is 5 metres, and it's 10 Newton metres. And because it's in the counterclockwise direction, that direction, it's positive. Okay, so let's adjust this system now, and let's say that we move the first force in. So we move that 2 Newton force into 4 units away. This one over here stays at 5. Okay, and we add another force here of 0.5 newtons. Can you now write down the equations for this system for the moments due to these forces around the point P? Stop the video and have a go. Okay, we can see that the moments due to both of these forces, they're both acting through this line of action along that perpendicular. So we have, due to the 2 Newton force, it's 2 newtons times 4 metres, and due to the 0.5 newtons, it's 0.5 newtons times 4 metres. So together that's 2.5 newtons times 4 metres, which is equal to 10 Newton metres as before. So we moved something in, but then we added a weight. So while the perpendicular arm was smaller, the force was greater, and we ended up with the same overall moment, which is in the negative direction. And over here, once again, the force times the perpendicular distance. The moment is the force times the perpendicular distance, which is equal to 2 newtons, and the perpendicular line back to the fulcrum is 5 metres, so that's 10 Newton metres, and it's in the positive direction because it's in the counterclockwise direction. Okay, finally, what would happen if we added an extra beam here, and at 1 metre away we applied a 1 Newton force? So we'll keep our 2 and our 0.5 newtons here, we'll keep our 2 newtons here, but now we've got an extra force happening down there. Let's say that this beam itself weighs 0.5 of a Newton. Okay, so how do we write the equations for that system? Stop the video and have a go. Okay, well let's see. As before, this moment here is equal to 2.5, the total force down along that line of action, times its perpendicular distance, which is 4 Newton, which is 10 Newton meters, and it's in the clockwise direction, so it's negative. And this one over here, as before, is 10 Newton meters. But what's happening here? Well, let's consider it. The actual weight is creating a 5 Newton force, but it's down through, 0.5 Newton force, but it's down through the centre. So is the weight creating any moment? No, because there is no perpendicular distance from the weight of the bar. However, the force being applied to the bar is at 1 metre away, and it's perpendicular to the moment arm. So we know that it will apply a moment. So the moment here is the force times the perpendicular distance, which is the force along its line of action, which is that line there. So that's 1 Newton acting along there, and the perpendicular distance from that line of action back to the pivot point is also 1 metre. So we have 1 Newton metre acting from that force. So the total moments in this system, the sum of the moments, would be equal to positive 10 from this one here. Just remember that that's positive because it's counterclockwise. This one here is also in the positive direction because it's counterclockwise. And this one here is in the negative direction. So altogether, these two cancel and we have plus 1 Newton metre. So that means overall this system is experiencing 1 Newton metre in the counterclockwise direction, so it will be tipping in that direction. So any system that you see where you have vertical and horizontal components, you can use this type of understanding where you look at a line of action and the perpendicular back, the fulcrum, you multiply those two together to get the moment. And any system that has verticals and horizontals, you can reduce to looking at the verticals and horizontals to look at the total moments around a point.